In a warship, the electrical systems are bonded to the ship's hull. The purpose of bonding to the hull is to provide a common reference point for all electrical circuits within the vessel and to ensure that all metallic surfaces maintain the same electrical potential. This is a crucial aspect of electrical safety and equipment protection in the marine environment. The ship's hull is also connected to the surrounding seawater, establishing a low resistance path to ground. This connection to ground through the seawater is an important safety feature. The generator is not utilized as the reference point for bonding. This is because the generator's operation is intermittent, meaning it is not always actively generating power. The primary power source for the warship's electrical systems typically comes from the ship's main switchboard. This switchboard is directly connected to the hull. Bonding all metallic surfaces to the hull is essential to eliminate any potential differences between various parts of the ship. These potential differences, if present, could lead to electrical shocks for personnel or cause damage to sensitive equipment. Furthermore, the bonding system provides a level of protection for the ship against electrical hazards, including lightning strikes. When lightning strikes a ship, the bonding system helps to distribute the electrical current safely through the hull and into the seawater, minimizing the risk of damage. Now let's delve deeper into the concepts of bonding, grounding, and their applications in marine electrical systems. Bonding refers to the practice of connecting all non-current carrying metallic parts of an electrical system together to create a continuous electrical path. Grounding, on the other hand, involves connecting this bonded system to a reference point, typically the earth or, in the case of a ship, the hull and seawater. The combination of bonding and grounding ensures that any fault current, such as a short circuit, has a low impedance path to flow back to the source, tripping a circuit breaker or fuse into energizing the circuit quickly. This protects both personnel and equipment from harm. In a warship, the hull serves as the primary grounding electrode. All metallic components, including enclosures, conduits, and equipment frames, are bonded to the hull using appropriate bonding conductors and techniques. The size and material of the bonding conductors are carefully selected to ensure that they can safely carry the maximum fault current that may occur. The bonding connections must be mechanically strong and corrosion resistant to withstand the harsh marine environment. The electrical system in a warship typically operates at various voltage levels, including alternating current and direct current systems. The bonding and grounding requirements apply to all electrical systems regardless of their voltage or type. It's important to note that the bonding and grounding practices in a warship are governed by strict regulations and standards, such as those set forth by the International Electrotechnical Commission, the Institute of Electrical and Electronics Engineers, and naval authorities. These standards specify the requirements for bonding conductor size, materials, installation methods, and testing procedures. Regular inspections and testing of the bonding and grounding system are essential to ensure its effectiveness and integrity. These inspections should include visual checks of bonding connections, insulation resistance measurements, and ground impedance testing. Any deficiencies identified during inspections must be promptly addressed to maintain the safety and reliability of the electrical system. The principles of bonding and grounding extend beyond the main electrical systems of the warship. They also apply to auxiliary systems such as communication equipment, navigation systems, and weapons systems. All metallic components of these systems must be properly bonded to the hull to ensure electrical safety and prevent electromagnetic interference. In addition to protecting against electrical shocks and equipment damage, bonding and grounding also play a role in minimizing electromagnetic interference. Electromagnetic interference can disrupt the operation of sensitive electronic equipment, leading to malfunctions or errors. By providing a lower impedance path for stray currents, bonding and grounding help to reduce electromagnetic noise and improve the overall performance of the electrical systems. Furthermore, the bonding and grounding system contributes to the overall survivability of the warship. In the event of damage to the ship, such as a hull breach, the bonding system can help to prevent the spread of electrical faults and maintain the integrity of critical systems. This is particularly important in combat situations where the ship may be subjected to enemy fire or other hazards. The design and installation of the bonding and grounding system in a warship are complex tasks that require specialized knowledge and expertise. Electrical engineers, technicians, and naval architects work together to ensure that the system meets the stringent requirements for safety, reliability, and performance. The selection of appropriate bonding materials is crucial for the long-term performance of the system. Materials commonly used for bonding conductors include copper, aluminum, and stainless steel. The choice of material depends on factors such as conductivity, corrosion resistance, and mechanical strength. Copper is often preferred for its high conductivity, but it is susceptible to corrosion in marine environments. Aluminum is lightweight and corrosion resistant, but it has lower conductivity than copper. Stainless steel offers excellent corrosion resistance, but it is more expensive than other materials. The installation of bonding conductors requires careful attention to detail. The conductors must be securely fastened to the metallic surfaces using appropriate hardware, such as bolts, clamps, and lugs. The connections must be clean and free of corrosion to ensure a low impedance path. The bonding conductors should be routed in a manner that minimizes the risk of damage or chafing. Regular maintenance of the bonding and grounding system is essential to ensure its continued effectiveness. Maintenance activities include visual inspections, cleaning of connections, and testing of insulation resistance. Any corroded or damaged bonding conductor should be replaced promptly. The grounding electrode, which in this case is the ship's hull, should also be inspected regularly for signs of corrosion or damage. The hull should be cleaned and coated with anti-fouling paint to prevent corrosion and maintain a low resistance path to seawater. The bonding and grounding system is an integral part of the overall electrical safety program on a warship. All personnel who work on or around electrical equipment must be trained in the principles of bonding and grounding and the potential hazards of electrical shock. Training should include instruction on the proper use of personal protective equipment such as insulated gloves and footwear. Warning signs and labels should be posted in areas where electrical hazards exist. The electrical system on a warship is a complex and critical system that requires careful design, installation, and maintenance. The bonding and grounding system is an essential component of this system, providing protection against electrical shock, equipment damage, and electromagnetic interference. By adhering to strict regulations and standards, and by implementing a comprehensive electrical safety program, the warship can ensure the safety of its personnel and the reliability of its electrical systems. In summary, bonding in a warship ensures all metal parts are electrically connected. Grounding connects this bonded system to the hull and seawater. This minimizes electrical shock hazards and protects equipment. Regular inspections and maintenance are critical for safety. Proper bonding and grounding are essential for a warship's reliable operation. The system protects against lightning strikes and interference.